Are you facing motor burnouts in your industry and buildings? How you can economically protect your motor? Let us go in depth. Your motor burns out due to poor protections now. Your motor may fail due to overstraining or overloading due to the loaded machine, or due to the current unbalance across the input three-phase supply, or the motor incoming voltages are either too high or too low. The motor burns out are prone to damage in front of your eyes due to the slow and sluggish protection of the thermal overload relays, and the poor quality lubrication of the motor bearing, and the blocked ventilation, etc. So, visualize in any of your machine incoming or the DB or the SSB, one main phase contact has gone loose and current unbalance happens, and the thermal oiler does not protect at some times of the day. The current unbalance condition can happen to motor at any time of the day. Assuming the motor life for a decade, you run your motor continuously, often to match the machine loads all along, but the slow response of the OLR does not protect. Thanks to the Bureau of Energy Efficiency guidelines on the motor maintenance practices, the direct and indirect reasons for your motor failure. You can see the direct reasons of the winding failure. It can happen due to the voltage fluctuation at the incoming or the voltage unbalance that is happening at the terminals of your motor. And the winding failure due to indirect reasons is the improper lubrication given to the motor and the defective bearing or the blocked ventilation in the motor. You are setting your thermal overload relay to suit your motor running current, and still this fails to protect your motor sometimes. If your motor has a cold start or a hot running start or restarting after when it is fully loaded, this thermal oiler does not protect your motor sometimes. The motor thermal withstanding conditions mismatch the oiler during the harsh ambient conditions. The current unbalance in the windings due to the motor internal problem or single phasing at the incoming or either at the motor panel or at the SSB, at the time also this thermal oiler does not protect your motor. The thermal oiler not timely responding to the overloading spikes, or it fails in the safe mode whereas the motor gets burnt out. Even the voltage sensing preventer that is used in your motor protection panel, it is to protect the motor at the incoming of the motor panel only, and it does not protect your motor. But the current sensing OLR type is a foolproof device to be fully protecting the motor up to its winding. The motor's protection and trip time duration must follow the IDMT curve, that is the inverse definite minimum time protective relay characteristic, when the operating time is inversely proportional to the fault current up to a point, after which time it becomes a definite minimum time. This is settable from 2 to 10 seconds in an electronic OLR as such. This is inversely proportional to the fault current up to a point, and this higher the fault current can cause the relay to trip faster, and the lower over currents can result in longer delays. And the electronic OLR precisely follows the overload and matches perfectly and protects your motor fully. Be aware of your motor protection during the single phasing condition. Under the circumstances during single phasing, when the EB supply is available in L1, you can refer to the figure at the bottom. At L1 and L3 only the supply is available, and the L2 the phase is open. The current undertaken by the windings at ABC on the delta connected motor, and you can see in the next page how is the motor behaving at different types of loading. The behavior of the thermal OLR, how it is happening here. Kind courtesy the Minilec brand technical notes on the thermal overload relay. It is an excellent case study on the thermal overload relay, and each and every industry needs to go through this case study. You can see for the given percentage rated full load current, all are expressed in terms of percentage of the rated full load current at 50%, 57%, 75% and 100%. You can see the line current in the phase L1 and L3, the phase current in the windings A, B, and the phase current in the winding C. It's a typical case study working on the given thermal overload relay, how it behaves in the single phasing condition. At 50% of the motor loading, the phase current in C is around 110%. The bimetallic relay does not operate. The motor may or may not burn at this condition. At 57%, you can see the phase current in this C winding has gone to 120%. Here also the bimetal thermal relay does not trip and the motor may burn out. At 75% of the motor loading, you can see the line currents on L1 and L3 and the phase currents, but the phase current in winding C has gone to 180%, and definitely the bimetal relay may operate, but it is sluggish to operate to protect the motor, and the motor goes for burnout before the thermal relay operates. At 100% of the motor loading, you can see the phase current in the winding C has gone to 280%. The extent of overload relay is very high. Bimetal relay will definitely operate and will save the motor at 100% of the loading, but we are more working the motors at part loading only in our industry, and this is where the electronic overload relay is definitely mandatory for the existing motor applications. The electronic motor protection relay is an economical alternative to your existing thermal overload relay, and it gives a foolproof, accurate, precise, repeatable and reliable protection to your motor against the burnout. The relay operates basically on the negative sequence current component sensing principle. This relay works along with the external current sensor to suit to the motor current. It gives a 100% protection to your motor against overloading or phase failure or phase sequence reversal or current unbalance, or in the case of a pump protection relay, even for underloading also it gives a protection. And thanks to the Minilec brand, the kind courtesy, the image, and many other brands are also available, and many of the machine OEMs, the special purpose machine OEMs have started implementing this type of electronic OLR to safeguard their machines and motors using this type of electronic relays. Again, thanks to the Bureau of Energy Efficiency discussing about the root cause of the motor failures. The burnout statistics in the prevailing industry motors, it's really an eye opener to the industry maintenance, and each and every industry needs to go through this content to know or analyze the root cause of the failures. You can see the category wise, the motor design or the power quality or the operation and maintenance of motor. The contribution to the motor failure is high in only few cases. Let us say the voltage fluctuation or voltage imbalance due to loose or corrosive contacts, this is high contribution. And then the operation and maintenance wise, improper lubrication, defective bearing, misalignment and mechanical looseness, this causes the high contribution towards motor failure. So you look into this aspect when you are anticipating any motor failure or why the rewinding is happening. These are all the areas to be addressed to now. The condition now, the prevailing in the industry is, the industry cannot wait for the fourth rewinding to happen in your motor. You can see the diagram below. It is taken from the notice board for a given industry where we have done the audit, energy audit. We have noticed and we also told the industry how to immediately replace your motor after the first rewinding happening in the motor. After the first rewinding, the industry has to monitor the motor no load and load related kilowatt losses, and instead of going for a second or say third rewinding, it is better to replace for a new IE3 version or IE4 motor for their 24/7 running machine, because this caters to a flat and excellent efficiency over a wide range of loading. First, you replace your motor thermal overload relay to the electronic overload relays, and this will protect the motor from further burnouts in case of any hazardous conditions from now on. This is a wake-up call to all the industries to go for a electronic OLR. It can be a motor protection relay or a pump protection relay. We are in the process of conversion from our decades old multiple rewounded motors to new IE3 motors, but simultaneously plan to add this OLR, electronic OLR, instead of a thermal OLR relay. The machines like AC&R machines or screw compressors or blowers or elevators, lift elevators or hoists and cranes or special purpose machines, they definitely need this type of electronic OLRs. Even the remote air handling units or the air washer blower fan motors, which start with a higher torque, heavy torque during the centrifugal impeller operation, they also need the electronic boiler relay to protect the motor from burnout. The crusher motors, mining machine motors, the power presses, and in the material handling motors like the conveyors, etc., where the stress on the motor is very high during the static type as well as during the heavy material loading happening, harsh and heavy starting and fluctuating loads, this electronic overload relay definitely protects your motor. The air conditioning centralized packages also the AC outdoors or the AC compressors. These need the electronic motor protection relay and the pump protection relay, which has an undercurrent setting also, which in case of any minute freon gas leaking in the outdoor, then automatically this gives an alarm and it can trip the outdoor and it can protect your air conditioning system. Plenty of these energy efficient case studies practices have been discussed in these books, and the link to buy I have just given here. But the point emphasized here is electronic OLR needs to be made mandatory in a 3-phase motor application to offer foolproof protection to the motor now. Let us please be clear that this content is not to promote any brand, but any cost effective thermal OLR to be avoided and electronic OLR to be taken into the industry, but the electronic OLR is a must to protect them from the motor burnout. It needs to be a must in the industry hereafter to protect your motor burnouts. Once the motor burnout happens in your industry premises, the motor efficiency also drops drastically, and it is a varying drop of efficiency depending on the nature of the previous motor burnout. When the motor running cost is more than 90% of the purchase cost, don't allow your motor to burn out. This electronic OLR will protect your motor not to burn out and avoid repeated motor rewinding. Hence, indirectly helps to maintain its existing motor efficiency sustainably. Thank you. Thank you.